Today we're going to be talking about nomenclature. Specifically, nomenclature composed of when a compound is composed of two elements. Now, nomenclatures are generally simple, a generally simple subject or topic, and there's two classes to nomenclature. There's binary ionic compounds and nomenclature involving binary covalent compounds. Binary ionic compounds, which you may know by now, ionic means a compound composed of a metal and a nonmetal, and covalent means a compound composed of two nonmetals. So we'll talk about binary ionic compounds first. Well, for the first step of naming a binary ionic compound is that the cation is always named first and the anion is named second. The cations are generally, on the left side of the periodic table. So the first four, technically, groups are cations, and then the next four groups are anions. So that's the first rule. The second rule is that simple cations are named from their element. So this involves memorization. Na plus, for example, is sodium. K plus is potassium. You need to sort of memorize the element names. Yeah. Third rule is that simple anions are named by taking the root and adding "ide" at the end, IDE. So for chlorine, its root is chlor, and once you add, so you get chlor, CHLOR, and by its rule you add "ide" at the end, so chloride. And so NaCl is sodium chloride, as you may know, or table salt. And that's generally what you need to know for binary ionic compounds. Alright, so now we'll talk about binary covalent compounds, which basically means that there's two nonmetals. And like I said earlier, nonmetals are generally on the right side of the periodic table. So the first step to naming a covalent compound is that the first element in the formula is named using its full name. So C would be carbon. That's basically it for that. The second rule is that the second element is named as though it is an anion, which means that it has IDE at the end. And finally, when it's a covalent compound, you must assign prefixes. We'll talk about that more in depth here. Prefixes are used to denote the number of atoms present. So, if there are two atoms in a molecule, then it would be di. Di, insert name, IDE. So 3 would be tri, 4 would be tetra, 5 would be penta, 6 would be hexa, 7 would be hepta, 8 would be octa, 9 would be nona, and 10 would be deca. Mono is a special case because you can only put mono for the second element of a covalent compound. You do not add mono to the first element. So,
Okay.
Let's try out some examples. These are, sorry for the bad handwriting. I'll give you a couple of seconds to try it out on your own. You could pause the screen and try it out for yourself. So let's get started. First of all, this is a ionic compound since it has a metal and a non-metal. metal sodium and non-metal chlorine, a gas actually. And this is simply, I haven't mentioned it before, sodium chloride, aka table salt. This one's very simple. This will be mentioned a ton of times in your chemistry class. What next? Okay, this one's a little more complicated. This is actually a covalent compound since it's two nonmetals, it's two gases, nitrogen and oxygen. So, what do you think we should do? The first step is that we should look at how many atoms each element has. So, since there's two, that's automatically di. So this is dinitrogen, because you keep the first element as its full name, and this is 3, so that is, again, you use a prefix, trioxide, and you finish with an IDE. For oxygen, its root is OX, ox. So you do trioxide. Pretty self-explanatory. It's whatever sounds best. Usually, it usually comes naturally. And finally, exact same procedure as this one, just a couple more atoms on oxygen. So, dinitrogen pent, since there's 5 atoms, oxide. And that's essentially it. So there's one last part to nomenclature actually, and I'll do it right here. I'll just write that, sorry about that. That last part, this one is the hardest part of nomenclature, if you can consider it hard. What just happened? Okay. So, they are what is going on? So let's talk about the final part of nomenclature, the hardest part of nomenclature, due to its fundamental property of memorization, polyatomic ions. There's no sort of easy explanation for them. You sort of need to memorize them from a list. I'll insert a picture of a list after this clip, and it's essentially just memorization. You just gotta look over that list a couple of times and you'll get it eventually. It's once you get them, they stick. Polyatomic ions are easily the hardest part. And to finish off, I guess, I'm gonna look at this. Like this video if it helped you at all, and subscribe. Now, this is nomenclature. This is going from compounds to nomenclature, naming compounds. But there's also the reverse process of getting the name and from that figuring out its compound. That's a little more complicated, and that's a subject for another video. However, I will be posting a video on that soon, and it all has to do with charges essentially, and charges and atoms. And that's essentially it. Anyway, I hope you enjoyed this video. Like and subscribe. And till the next time. Bye.